Hello friends, welcome to our channel Classical Coding. Today we'll discuss another important interview topics, that is singleton design pattern. First we'll learn what is design pattern. In simple words, it denotes the best practices or solution for general problem. Now the simplest design pattern, that is singleton. So singleton is a creational design pattern. Why it is creational? Because it denotes how the object will be created, and it ensures only single object or instance will be created into the JVM. There are mainly two types of singleton design pattern. One is early instantiation and another one lazy instantiation. So what is early instantiation? Here the instance is created at the load time when the class is loaded. And in case of lazy instantiation, the creation of the instance is happened when it is required. Let's discuss about early instantiation of singleton. In this scenario, the instance of the class is created at the time of class loading using static data member. Let's discuss one example. So here in the early instantiation singleton class, we have one static data member, that is obj, and we have one default constructor, and we have a get early instantiation singleton method. So it returns the object when we need the object. So in the time of class loading, as the instance is declared using static keyword, so the new operator will be executed and the instance of the class will be created. So before the requirement, in the time of class loading, the object is created. That's why it is early instantiation. Before requirement, object is created. It is created early. The next one we will discuss about the lazy instantiation. So what is lazy instantiation? In these cases, the instance of the class is created in synchronized method or within the synchronized block. So the instance can be created when it is required. Let's discuss about one example of lazy instantiation. We have created one get lazy instantiation singleton method, which returns one lazy instantiation singleton object. Within that method, we check whether the object is null or not. If it is null, then within the synchronized block, we create the lazy instantiation singleton object using the new keyword. And if already the object is present, that means the object is not null. In that case, it returns the existing object. Now we will discuss significance of serializations in singleton pattern. If a singleton class is serializable, then we can serialize the singleton instance. Once it is serialized, we can deserialize it, but it will not return the singleton object. So to resolve this issue, we have to override read resolve method and put our logic there, which will be called just after the object is deserialized and return the singleton object. Now take one example to understand more. So here we have one class, that is serialized singleton, which implements the serializable interface. And within that, we have override the read resolve method, which calls the get serialized singleton method, and which subsequently return the instance of serialized object, the singleton object. So this is the code snippet for that. Let's start our coding. There we will implement our own singleton class, and we will run the code and check the output. So we have our example singleton class, and within that we have our static data member, that is instance. Now we will create the default constructor, and that should be private. We'll introduce another data member, that is test int, so that we can check that how the singleton is behaving. Here we are using the volatile keyword because in a multi-threaded environment, if we use the volatile keyword, then one single thread can get a lock of this specific data member at a time. Now we will write our get instance method. First, we'll check that whether the instance is null or not. First, the null check. If it is null, then we'll create a new instance. But if it is not null, then what will happen? It will return the existing one. Now we will write our driver logic within the public static void main. First, we'll try to create 3 instances of example singleton class, and we'll populate those test int with different integer. Say we are putting value as 1. Now we'll create second and assign 2 within test int. Now we'll create third and assign 3 within test int. Now we'll print 3 instances, first, second, and third, and also their test int data member. That's it. Before running our code, we should declare our test int data member as static, because as it is a singleton design pattern, that's why only one instance needs to be created. So let's run and check our output. So we have 3 instances which is created using new operator, but we can check for all cases the value is 3. That means it is pointing to a single instance. Let's try to write our code using the get instance method. Here all the values is changed to 4. That means if we change the value of test int, as only single instance is created, that's why it impacted all other cases. Thanks everyone for watching our video till end. Kindly share your feedback in the comment section. If you enjoyed our video, please like, share, and subscribe to our channel. We try to put new videos every week. Thank you.